So how many of you remember what we have studied so far? How many of you remember what we have done so far since beginning? I know, blank faces. Okay. So that's the reason we quickly recap some theoretical concepts of what we have done and what all exercises we have covered, how did we do them for 10-15 minutes, and then we'll start with new exercise today. Okay. So what did we start in deep learning? We have started building which models? ANN models. ANN stands for what? Artificial neural networks. Okay. So we have started working on neural networks, and then we have studied about different activation functions, loss functions, and different optimizers. Okay. So we were talking about how do we build a artificial neural networks. We have seen three important steps in which we build an artificial neural network. What are they? Forward propagation, loss function, backward propagation, right? So we have seen what are different loss functions. We have seen activation function. In forward propagation we use activation functions. After that, in second step we use loss function to calculate the error, and then to reduce that error we go for backward propagation, wherein we change the optimizers. Okay. So this was first step. What was that? To build an ANN, what did we do? We have to initialize the network architecture. So how does your ANN architecture looks like? It has three layers: input layer, hidden layers, and output layer, right? Okay. So what do we do after we initialize the network? Depending upon how many hidden layers we take, for each and every hidden layer we have to define what? Activation functions. What does activation functions do? They introduce non-linearity in the data such that the complex patterns would be identified and will be able to make the predictions. Right? After we go for forward propagation, calculating all this, what do we do? Loss function. What is loss function? What are loss functions? They are actually used for predicting the error. Okay, how do we calculate error? Predicted actual output minus predicted output. Okay. So after we define the loss function, what do we do? We have seen two types of loss functions. What are they? Mean square error and cross entropy. When do we use mean square error? Emma, stop discussing. Close your laptop. Stop. So what? When do we use MSE? Mean square error? When we deal with which task? Regression task. When we have classification task, we use binary cross entropy. What is regression and what is classification?
Regression when you have continuous value.
When do we use regression algorithm? When the output variable has continuous values. When do we use classification task? When the output variable has discrete values, right? We have again two types of entropy. What are they? Binary cross entropy, categorical cross entropy. When do we use binary and when do we use categorical? When we have only two possibilities of output, we use binary cross entropy. When we have multi-classes in the output, we go for categorical cross entropy. This is how we define a loss function. After that, the next step would be backward propagation. Why do we go for backward propagation? To reduce the error, right? So what do we do actually in backward propagation? We adjust weights and biases. In forward propagation, the equation is given by what? Summation of xw plus b. Okay, the function, transfer function is given by summation of xw plus b. What is this x? The inputs. What is w? The weights that we add, random weights that we add. What is b? The bias that we add. This is forward propagation. After forward propagation, we calculate the loss function. If the loss function is more, which represents the error is high, and hence we are supposed to go for backward propagation, wherein we adjust what? Weights and biases. Right? So what do we do in backward propagation? We use different optimizers. Why do we use different optimizers? Such that the way we adjust the weights would be different. So we have seen two different types of optimizers. One is gradient descent, the basic one which we use in deep learning, wherein we calculate the loss function with respect to hidden layers, with respect to weights and biases and all that, and then we calculate the new weights and biases and then go for forward propagation and repeat the process. Apart from gradient descent, in the last session we have also seen another type of optimizers which is called as what? Adam optimizer, right? So what does optimizers do? Optimizers will ensure that the weights and biases are properly adjusted such that my error function would be reduced, right? After we go for backward propagation, what do? We start training the network. So what are the 3 steps that we use in training the network? Forward propagation, loss calculation, backward propagation, and repeat the process iteratively till you get the desired accuracy or till the cost function is gradually reduced, right? Now, this was the entire architecture of how did we build all the ANN models, right? So the 3 core components that we have focused on to improve the performance or to generate a proper AI model, proper ANN model is what? We have focused on what? Activation functions, we have focused on loss functions, we have focused on optimizers. If you properly know the activation functions, how to choose an activation function, which activation function to be chosen for the hidden layer, which activation function for the output layer, that part would be done. That is the forward propagation part. Depending upon the task that we carry on, whether it is classification or regression, we have to choose the proper loss function. And after that, depending upon the model that we work on, depending on the data that we have to choose the proper optimizers. Okay. So most probably in deep learning, we will be using Adam optimizer or gradient descent algorithm, which we have already finished in the last sessions. Okay. So these are the core components which will actually affect the performance of any ANN model. What are they? Different activation functions, loss functions, and then optimizers. Okay. Now, so let's quickly recap the activation functions once. Okay. So why do we use activation functions again? To introduce non-linearity in the data such that the weights and biases would be properly taken into consideration and the neurons which actually has the information would be activated and output would be produced. Okay. So we have focused on 4 different types of activation functions. What were they? We have seen sigmoid, tanh, ReLU, softmax. When do we use sigmoid? For binary classification where you want to map the input between 0 to 1, we use what? Sigmoid. Okay. Basically sigmoid is used in a hidden layer. Okay. For binary classification task. When you are looking into classification task, that to binary values, for the hidden layers we will be using what? Sigmoid. Okay. When do we use tanh? If the values are between -1 to 1, if the range of values, continuous values, if you have continuous values in between -1 to 1, we will be using what? Tanh. Other than tanh, there is another one which is also called as what? ReLU, which is most probably used when we carry on with our regression task. Okay. After that, we have another activation function which is called as what? Softmax, which actually gives the probability. When you have continuous values, but you have to predict the classification. Okay, that is probability of a person getting passed. See, the pass mark cutoff is 35 for 100 in general. Okay, so beyond 35, 35, 45, 55, 65, everything is considered as what? Pass. Below 35 it is considered as fail. So though I have different range of values, I am supposed to tell either it is pass or fail. Are you getting my point? So here I have to go for taking continuous values. She has 75%, she has 85%, they have 20%, they have 30%. The percentage is different, but I have only 2 categories of output, pass or fail. So I have to calculate the probability putting a saturation level. For that cases we go for which activation function? Softmax, which we will be using today. Please make a note of that. Okay. So when you want to know the probability of the value and define that as a classification task, we will be using this activation function which is called as what? Softmax. So most probably we will be using softmax at the output layer. Why am I focusing it on the output layer? Because the output probability should be calculated and it should be given as yes or no even if I have continuous values. Please make a note of this point. Okay. So these are the 4 activation functions which we have focused on earlier. Okay. And then we have focused on 3 important loss functions. What are they? Mean square error, binary cross entropy, categorical cross entropy. When do we use mean square error? For regression task. When do we use binary cross entropy? When the output has only two different possibilities, yes or no, true or false. When do we use categorical cross entropy? Multiclass. When I give you three different classes, okay, good, very good, excellent. Rate my class, good, very good, excellent. So how many classes do I have here? Three. Okay, based on the probability of my teaching, you either grade me into good, very good or excellent. Okay, three categories. So in this case, we go for which classification? Categorical cross entropy for the loss function. Today we will be using this. Softmax and categorical cross entropy. Okay. And then we have seen different types of optimizers. Why do we use optimizers? To adjust weights and biases in such a way that my loss function would be gradually reduced. So we have seen two major different types of optimizers, gradient descent and adder. In gradient descent again we have three types of gradient descent. What are they? Batch, stochastic, mini batch. Okay. And then we have seen another different type of optimizer which is called as what? Adder. What does ADAM stands for? Adaptive momentum based optimizer. Okay. So we have seen all this in the theoretical concepts which we have discussed so far. Okay. Now let's quickly recap the three exercises which we have already done. Okay. So what was our exercise 1? What was our exercise 1? Okay. Build an AMN model that is regression on which data set? Insurance data set. Okay. We focused on building a simple neural network for regression tasks. And what was the data set that we have used? Insurance. So why did I choose regression for this insurance data set? No discussions at the back, please. So what was that? Why did we choose regression for insurance data set? Because the regression data set has the output variable which had continuous values. That is the reason for this particular data set we have chosen regression algorithm. Okay. Now, so first thing is we have to define the basic structure of ANN and then forward propagation. So in forward propagation, after forward propagation we have used loss function which was MSE, and then we have calculated backward propagation with which algorithm? Gradient descent. This is what we have done for first exercise. So what did we understand from exercise 1? We had a good understanding on what? How does ANN architecture looks like and how the data flows. How the data flows? Forward propagation with respect to xi wi plus b summation, loss function, backward propagation. This is a three-step data flow. And then we have explored the role of forward propagation. Why do we go for forward propagation? And then we've also worked on with loss function, that is MSE, and then we have applied gradient descent to train the model. Okay. What did we do in exercise 2? Classification on what? Churn modeling. What was churn modeling? What is this churn modeling? To check if a customer will continue or exit. Okay, whether student will continue the class or exit the class based on what's going on here. Yes or no. So as the data is yes or no, only two possibilities. We have chosen which task here? Classification task. Okay. So we are focused on applying ANN for a binary classification task predicting customer churn. Okay. So here we have done binary classification. We have changed the loss function here. In the first exercise we have used what? MSE. Here we have changed the loss function which was what? Binary cross entropy. And we have used the same gradient descent for classification. Okay. So what you have to understand here is in exercise 1 we have used the same gradient descent, but we have changed the loss function because first exercise was on regression, second exercise was on classification. Okay. So what did we do here? We have worked with binary cross entropy and then we have learned how to evaluate classification model with respect to accuracy. Okay. Yes. So what did we do in exercise 3? Again we have gone back to regression on same insurance data set, but here we have changed to what? Optimizer. First exercise was same insurance data set regression but using gradient descent. Here same regression insurance data set but we have changed to what? Optimizers. Which optimizer did we use in exercise 3? ADAM optimizer. Right? So here we have studied about different optimization techniques, and then we have focused on one important optimizer, which was Adam. Okay. Yes. So this is our exercise that we are going to concentrate today. Okay. So far what did we do? Regression and classification. That's it. Okay. In regression on insurance with MSE with gradient descent. Regression on insurance with binary cross entropy loss function and Adam optimizer. Okay. We've also seen classification with what? Regression with mean square error and optimizer change. Classification with what? Binary cross entropy. Okay. So far for these three exercises we have used only one layer ANN, right? Only input layer, hidden layer, output layer. Okay. So today in the exercise we are going to concentrate on many different things. So as you can see the title, the exercise we are going to work on is multi-layer, multi-class classification using what? ANN. What do you mean by multi-layer, multi-class ANN classification? We are not just taking one hidden layer here. From here onwards, we are trying to increase the number of hidden layers. Let's not take 3 or 4, let's take only 2. So how does our network looks like? Input layer, hidden layer 1, hidden layer 2, and then output layer. This is the first change that we are doing. What is the first change, guys? So far in the past 3 exercises, we have taken a simple neural network with one hidden layer, but here we are building a deep neural network with 2 hidden layers. So we have input layer, hidden layer 1, hidden layer 2, output layer. Is that clear, everybody? Yes or no? Okay. Now when I talk about multi-class classification, what do you mean by multi-class classification? The output layer does not have only 2 possibilities, but the output layer has 2 or more possibilities. We will not take 10 possibilities, we will take only 3 possibilities. Okay, instead of 2, we will go for 3 possibility classification. Is that clear, everybody? Yes or no? Now tell me, which activation functions do I use? Softmax at the output because I have multi-class classification. Okay, and for the hidden layers, let's use sigmoid. You can either use ReLU or you can use sigmoid depending upon the values again. If you have continuous values, you can use ReLU or sigmoid. Okay, for this exercise, we will be using sigmoid for the hidden layers. For the output layer, we will be using what? Softmax. Okay, this is one change, second change. What was first change? Instead of one hidden layer, we are taking 2 hidden layers. What is the second change? Activation functions. So which activation functions are we using in the hidden layer? Sigmoid. Which activation function are we using in the output layer? Softmax. Okay. How do we calculate loss function? MSE, BCE or CCE? CCE. Categorical cross entropy. Why? Multiclass. Okay. And then what will be the next change? Back propagation. Okay. So back propagation will once do with gradient, will once do with Adam, and then check the difference. So with this we will be done with 4 exercises and almost all the topics of building ANN will be covered. Is that clear, everybody? So this would be today, this session, and the next session will close ANN. From the next week we'll start with next type of neural network, which is CNN. Okay. So we will end ANN by focusing on these exercises where we will design ANN with what? Multi-layers, different type of loss function which is categorical cross entropy, and we will use 2 different optimizers. One is gradient descent, one is Adam, and check the difference between how the optimizers will affect the performance. Is that clear, everybody? Are you all okay with what are we going to do today and the next session? Yes? So let's quickly understand the steps. What do we do first theoretically, and then we'll switch on the exercise. Okay? So before I start with the exercise, I'll explain you about the data set that we are going to work on. Okay? So what was the data set that we have used for regression? Insurance data set. Right? What was the data set that we have worked for classification? Churn modeling. Okay? So the data set that we are going to work on for this particular exercise is iris flower data set. That is in machine learning, generally machine learning or deep learning, this is one of the most important or popular data set that everybody uses. Okay, what is the data set called as? Iris flower data set. The reason why we use this most frequently is it is already pre-processed. The data set is perfect, pre-processed and neatly arranged. Okay, that is the reason we choose this. Okay, now the data set has 4 different features. What do you mean by features? The input variables. Okay. So basically, iris flower data set is all about a flower called iris. Okay. So there are 3 categories of flowers. How many categories? 3. Let me show them. Yeah. This is an iris flower. Okay. As you can see, there are 3 classes. So first class of flower is called what? Setosa. Second category of flower is called what? Versicolor. Third category is called as what? Virginica. So that is the reason I have chosen this data set. Why? Because I want to focus on multi-class. There are 3 classes. What are they? Setosa, Virginica, Versicolor. Okay, I don't have 2 outputs, true or false cargo. I have 3 possibilities here. So that is the reason we call it as what? Multi-class. And input has 4 features. What are they? Sepal length, sepal width, petal length, petal width. Okay. What do you mean by sepal? As you can see in the picture there, the outer part, before we get that leaf, petal, the outer part is called sepal. So depending upon sepal length, sepal width, petal length and petal width, we will define which category does the flower belongs to. Okay. So this is how your data set looks like. Okay. So you have 4 input features: sepal length, sepal width, petal length, petal width. You have different range of values for sepal length, sepal width, petal length and petal width. Depending on these values, we will categorize the output, whether it is a setosa, versicolor or virginica. Observe the values and tell me when is that setosa, when is that versicolor, when is that virginica. Observe the values very carefully. When is a flower setosa? When is a flower called setosa? When the sepal length is too high, sepal width is moderate, whereas petal width is very small. If the petal width is very small, sepal is very high, we call that flower as what? Setosa. When do we call the flower as versicolor? Very high sepal length, moderate petal width. Okay. When do we categorize the flower into virginica? Moderate sepal length, high petal width. Okay. So this is our categorization. Your machine learning model, your ANN model also should understand these values and categorize the flower either into setosa, versicolor or virginica. Is it clear, everybody? So this is the data set that we are going to work on. Okay. So we totally have 150 rows of data. Okay, 150 rows of data with each flower of 50 instances. Setosa 50 different values, versicolor 50 different values, virginica 50 different values. Okay. Now let me tell you one more important point. The reason why I told this is a popular data set, right? The reason why we choose this is because this is already pre-processed. See, when we talk about a data set, okay, so why do we use this data set? To train a machine learning model, right? So when I take a data set, we divide the data into 2 parts. What are they? Training data and test data. What is training data and what is test data?
Data which the model is trained on and to test.
Training data is used for training the model such that the model will learn the patterns inside the data. After the model learns the data, we use the test data to check if the model is working properly or not. Yes or no? Yes or no? Yes. So we have a concept called balanced data set in machine learning or deep learning, which means if suppose I have a class of 60 students, okay, and I have 50 students who pass the exam, 50 students who fail the exam. Okay, so the data is equally distributed and I'll train the machine with pass students marks, fail student marks also. So my machine knows very well about with how many marks the student gets passed or how many marks student gets failed because it is trained equally on both types of data. Okay. So when you test with a new value, the machine may perform well or your model may perform well because it knows about the different patterns of pass and different patterns of fail. But if suppose I have a data set where I have 90 students who passed the exam, only 10 students who failed the exam. Okay, so as the failed percentage is very less, the machine may not learn much about the failed students. When I train the data more, when I test the data on more failed students, the machine may fail because I have imbalanced data set. What is that imbalanced data set? 90 are passed, 10 are failed. Okay, so when you have data sets like this, you have to do some pre-processing. Okay, so for this type of data set, we have 50 categories of versicolor, 50 categories of setosa, 50 colors of virginica. So in this case, we need not do pre-processing and all that. So machine learns very well with this type of data set, which is called as what? Balanced data set. Is it clear, everybody? So for that reason, we will be getting good accuracy when we choose this model. That is the reason many of them choose iris flower dataset for working on many different models. Okay. So did you understand the concept of balanced dataset and imbalanced dataset? Yes or no? Okay. So we'll see how do we build this exercise on. What is step 1? First is we have to import what? Libraries. So what are the libraries that we need to work on this? NumPy, Pandas, sklearn, and what? sklearn, that's it. Because standard scalar, train, test, split, everything from sklearn only. Pre-processing. Okay? Yeah. So from where do we get this iris dataset again? Okay. So far, for the previous exercise, we gave you the dataset path link, right? Yes or no? But for your information, there are few datasets which are available by default in sklearn. You can also read those datasets and work on them. You need not download from elsewhere. So iris flower dataset is by default available in sklearn. So you can simply import the datasets from sklearn library. Okay. So we didn't give you path. Don't get confused on where is the dataset. You have to download the dataset from sklearn library. Okay. So next is what? After we import the iris dataset from sklearn, we'll start reading the iris flower dataset and give the variables x and y. Okay. So after that we do what? One hot encoding. This is another new concept that I am going to introduce today. Okay. So we have seen standard scalar already, right? So here in this topic we will be using one hot encoding. Okay, I'll explain you what is one hot encoding, why do we need that, how do we do one hot encoding today. Okay. And next, one hot encoding is one pre-processing step. Okay, so we'll see why do we need one hot encoding, why did we choose one hot encoding here in this particular data set is what I'll explain you. Okay, and then after doing that, we go for splitting the data set into train and test, that is 80% training data, 20% test data, and then we'll standardize the features. What is the need for standardizing the features?
So that the machine doesn't assign more.
The machine does not understand that if the petal length is more, this is of higher value. All four has equal importance to decide whether it is versicolor, virginic or setosa. All three has equal importance. So we should explain the machine that by using what? Standardization. Okay. After this, we'll define the activation functions. So what are the activation functions that we are going to use? Sigmoid and softmax. Where do we use sigmoid and where do we use softmax? Look at that. Sigmoid for the hidden layers to introduce nonlinearity and softmax for the output layer for multi-class classification. As we have three different classes, setosa, versicolor and virginica, we use softmax. Okay. And then we define the neural network architecture, how many input layers, how many hidden layers and all that. After that, we initialize what? Weights and biases. And then we set learning parameters. As we use Adam, what is beta parameters and all that for Adam. And then we'll initialize movement vectors for Adam optimizer. After that, we define which type of loss function here? Categorical cross entropy. Okay. And then we'll train the model. How do we train the model? Forward pass, compute the loss, backward props, and then update weights and biases using the optimizer. Okay, print the loss function, evaluate, and then make predictions. So these 15 steps we are going to do today and in the next coming sessions. Is that clear? So what is our exercise that we are going to work on, guys? Multi-class, multi-layer, ANN model on which data set? Okay, so we'll on the exercise, we'll do step by step procedures. Now you can open your laptops. A1 is the task name. Please refresh your dashboards. The exercise name is given as Multilayer ANN Task 1 A1. Please refresh your dashboards. Import the libraries needed for data manipulation, data reading, splitting.
Announcement here. So most probably the study material is the PPT. Just ask the instructor to just convert it to PDF and it will be available in Tufan, the study material section. Okay? For both, for FSD, web development, plus the deep learning project.
By the end of the day, I'll upload all the PPTs that we have covered so far and upload it onto the Tufan. Okay, so you might be knowing about importing NumPy, but there's a new thing here from sklearn.datasets. Please check the second line. From sklearn.datasets, import load underscore iris. Okay, so we are using the iris dataset which is available in the sklearn module. Okay, so import NumPy as NP. From sklearn.datasets, import load underscore iris. The rest of them, you know that. The only thing is you have to import load iris from sklearn.datasets. Step 1. See, you have so many other different datasets on sklearn also. You can explore them and do that later. Okay. So we are using iris dataset for this exercise. Okay, let's check step 2. So what do we do in step 2? You have to load the iris data set. Okay, take a variable called data or something and then load iris data set into that and define x and y. X will have 4 different input features: sepal length, sepal width, petal length, petal width, and y will have the category. This is how we load the data set. I am just taking data as a variable and into that I am loading iris data set and x data. Okay, you can view your iris data set. You can read that, you can see the input features are given as data, which is x, and the output is given as target. Hence I give y is equal to data.target. Load the iris data into a variable called data, define x and define y. Define x and define y. X is the input where you have 4 features, y is the output target variable which has 3 classes. Okay, so did you all finish step 1 and 2? Reading the data set, importing the libraries. Okay, now you can pause for a while. I'll explain you what is one hot encoding, why is that required here. Okay, all of you please listen to this. This is the most important topic in machine learning, deep learning, or anywhere. Okay, listen to me. So why do we use one hot encoding? Please read the first line there. Read the first line. One hot encoding is used for converting target variable into one hot encoded format. What are we doing here? We are converting target variable, that is the output variable, into one hot encoded format. That is, look at this example. What is the data set? What is the data set that you see here? You have 2 columns. What is that first column? ID. Second column is what? Color. Now how many different types of colors I have? 5. What are they? Red, green, blue. 5 or 3 are? I have 3. Red, green and blue. I have 5 classes. I have 5 instances, but I have 3 classes. What are they? Red, green, blue. Now tell me, can we decide when are we getting red, when are we getting blue, when are we getting green here? Different input values may lead to different colors. I cannot just decide when do I get green, when do I get red, or when do I get blue. So that is the reason what we do is, look at this. We convert this one output variable or one column of target variable into 3 different columns. Okay. Now what did I do here? What did I do here? I have converted the target variable into different classes based on how many types of possibilities of output I have. In the color column, I had green, blue and red. So they are categorically mentioned. I don't want categorical mention here. I want whether it is green, whether it is blue, whether it is red. That is, I want to know if it is Setosa, Virginica or versicolor as separate classes. So what do? I convert one target variable of 3 classes into 3 different, only one target variable but with 3 different classes. Now look at the values in the 3 classes. In the previous case, whenever we have red, in class red I have 1, 1, the remaining instances will have zeros. In class green, look at that, second row and fourth row has green, hence in the second column for green, second row and fourth row has 1 value, the remaining has 0 values. Look at the last column, color blue. When do you have color blue? Only for the third column. So 1 would be represented only in the third column in the, third row of the column color blue, and the remaining would be zeros. So how do I obtain this? I want to convert this type of data set into this data set. So how do I do that? By using which method? One-hot encoding. What do you mean by one-hot encoding? Converting categorical output of different classes into binary output of the same class. Is it clear, everybody? So for which we will be using what? One-hot encoding. Okay. Now how do we do one-hot encoding is what I'll tell you now. Okay. So we have to define a function called what? One-hot encoding function. And you have to pass 2 parameters. What are the 2 parameters? Look at the bottom. One is called number of classes. The second one is called one-hot encoding output. What is this number of classes? How many classes of outputs you have? So in our data set of iris flower, how many classes we have? 3. So num underscore classes is equal to what? 3. What is one-hot encoded output? The new output that we are going to obtain. That is, we are going to change the data set from 1 target variable into 3 target variable of 3 classes. Is that clear, everybody? Okay. This is how I do it. Look at that. I am defining a function called one-hot encoding and I am passing 2 parameters. What are the parameters? Y, which is the target variable, and what? Number of classes. So within the target variable, I have these many classes. Please divide those into different target variables. And I am loading that into y underscore one-hot. Before I do that, I am returning one matrix. What is that? Why do we use the function I in NumPy? To get an identity matrix, right? So look at this. Look at that. If suppose I take number of classes is equal to 3, I will be getting an identity matrix with 3 rows and 3 columns, which represents 0, 1, 0, 1, 0, 0, 1, 0, 1, 0, 0, 0, 1. 1 for each class. 1 would be Setosa, 1 would be versicolor, 1 would be Virginica. Is that clear? So in order to generate an identity matrix with 0, 0, 1, 0, 1, 0, 1, 0, 0, which represents each class, I am using this particular function. Okay. Now look at the bottom. For example, if I have 0, 1, 2, 1 generated. Okay. So 0 represents 1, 0, 0, which is Setosa. 1 represents what? 0, 1, 0, which is second type of flower. 0, 0, 1 represents Virginica, which is another type of flower. Is that clear? So depending on those 150 instances, how they are arranged, I will be getting a matrix like this. Okay. So in order to generate this, we will write this particular block of code. What is that? Defining what? Defining what? One-hot encoding function. How many parameters are we passing here? 2. What are they? Y and number of classes. Here in our case, how many classes do we have? 3. Hence I am defining num underscore classes is equal to 3. Please complete this. In the same block. Don't take another exercise. X and Y. Okay. Not in the splitting, not in the step 3, step 2 itself. After you load the data, please perform one-hot encoding. In step 2 itself, perform one-hot encoding because I want to do standardization on the new obtained data. Okay. Define one hot encoding by passing two parameters. Define one hot encoding by passing two parameters, which is y and num classes. If suppose I take a data set where I work on giving the feedback on a subject with 4 classes, good, very good, excellent, outstanding. So what should be num underscore classes? 4. Depending on how many classes we have, we declare that instances here. Finished? Did you all finish performing one hot encoding? What is step 3 now? Split the data set and perform standardization. Please do that. You know how to standardize the data, right? Split the data set into train and test, 80% being training data, 20% being test data, and then standardize the features. Once you are done with one hot encoding, perform standardizing the features. Okay? Yes, did you all finish? Did you all finish step 3? Okay. How many of you got the test case passed? Only the one sitting front, listen, do, and then get the test case passed. Few in between. Complete standardizing the features, only 70 submissions out of 250 plus students.
Please submit. I just see this. Please, these are all graded exercises. You need to submit in the class itself. And I see almost only 100 to 120 people submitting out of 250. Are they really understanding, or they want to just sit idle? If that is the case, I think we need to take few other actions. So please ensure that your participation is in a two-way. So we encourage your participation. 5 minutes more, we'll start. Meanwhile, those who are completed, any questions here?
5 minutes for those who still didn't do that. Only 120 submissions here. We'll call your roll numbers if I don't see you working on that. Meanwhile, those who have completed, you can ask sir any questions if you have.
Okay, I have one question from one of your colleagues. Says about how the performance is enhanced using one code encoding. I think ASHA will just give you that answer. But meanwhile, other than that, any other answer? Any other questions? Okay, those who have done, please raise your hand. Okay. Others, we are giving you 5 minutes more. Please try it out, because the next exercise is based on what you have done in the previous. So ensure that we stop this exercise and we switch on the next. Your answer is already there. Okay, I have, by the way, 2 questions here. 2 questions, everyone. Question number 1. So, where do you get data sets from? Yes, few of your colleagues says from Kaggle. Very good. Other, let us say you don't find data set from Kaggle. Then what? Of course, that's the last remedy is to create your own data set. How do you create a data set, by the way? create a data set? By famous, one of the important it's a scanner. I think anyone, I just want to see anyone can talk about it. How do you get a data set? It's a famous code, by the way. It's a part of it. Okay, the tool that we generally use, I don't know, I want the name, but the tool that we use is called the Beautiful tool. What is the concept called as? There's another tool called Scrapy. We use these two tools to do something. What is that? Are you started working on your projects or not? So all of you got your data sets from Kaggle and all? Okay, we have got, okay. Let me see how many of you by end of the class or by end of this particular week will come up with their own data set. Let us see. Because here when you try to design a model, you need to have a data set. Number one. Number two, let us say you got a data set from Kaggle. This is the second question. How do you determine which model should I use? They're all predefined models. Yes? If you talk about machine learning, we have random forest, we have what? Linear. Yes or no? Regression, linear regression, sigmoid. But how do you determine? If you talk about deep learning, we have ANN, CNN, UNet, ResNet, transformers. But based on the data set, how do you determine which model should I select? Anyone? Based on the data set, how do you select a model? How do you, first of all, you should visualize. Whatever madam is teaching to write the code, you should have a visualization technique. Please visualize. But my question is not that, that will be the next part. But here I want to ask you a straightforward question based on the data set, how do you choose a model? Trial and error is resource intensive. If you are talking about, if you have a small data set and you're trying to use a model and check, you will not get the efficiency, you will not get that particular thing. So you need to go use the infrastructure in such a way, which is wrong. Yes? How do you select? Visualization is the key, but how do you visualize? Please, that's the reason. You question here. Madam has taken a data set and used multi. It's ANN, right? We use ANN for that IRIS data set. Why did we use it? Anybody knows? Why did we use ANN for IRIS data set? Okay, if there is an X-ray, just X-ray. Anyone? What data set I should use? Chest X-ray. I have images of chest X-ray. Very good. CNN, particularly UNet. CNN.
Data is not saving.
Because you convolute for every bits in a grid matrix, you check for segmentation and classification. That is how you visualize. Okay? Now, this is not a complete session here, but this is the building block. So please understand each step, what, how, and where. These three questions. Okay, how many of you completed the exercise so that I can just ask Asha to just...
We'll continue, sir. I'll continue.
Okay. Asha.
Yeah. So good question on why one hot encoding. Okay, I'll clear that point again here. We use one hot encoding basically to convert the strings into numericals firstly. Okay, you can ask me, we can convert blue, green, red into 0, 1, 2, no. That is called label encoding. Okay, but we don't use label encoding because again, the machine may think if I put 0, 1, 2 for Setosa, versicolor and Virginica, machine learning model may think 2 is a bigger value and Virginica has more importance. Okay, so even when you do one standardizing, you're standardizing the input variables. but not the output feature here. We do standardization for what? Input values such that all of them appear same. We don't do standardization for the output variable. Okay. So basically we have this label encoding concept which is converting what? Strings to numbers. Basically strings are difficult to process. Hence we convert that strings into some labels which is called label encoding. I want to give equal importance to all the three classes. Hence I can't put 0, 1, 2. So I go for what? Label encoding giving 0, 0, 1, 1, 0, 0, 0, 1, 1, different type of technique. Is it clear? Such that the machine will not interpret one output variable to have more importance and other output variable to have less importance. That is the reason we go for one hot encoding. Is it clear everybody? Yes or no? Okay. So did you all complete this one? Okay. Next, in task 2, we will define the architecture. Okay. How many layers we have now? 2 hidden layers. One input layer, 2 hidden layers, and then one output layer. We'll on assignment 2, please do that. Okay. I'll just quickly give a glance of the code and then remove that. Please look at that. So I am initializing what? Input size, hidden size. I am also initializing weights of the hidden state 1 and 2 and then the output. Okay. Try doing that. We'll continue this in the next class. We'll do the test case later. Just as we have 5 minutes time, you just type the code input. In the next session, we will try to complete this. Try initializing weights and biases. See, remember about label encoding, one hot encoding. This is very important. Label encoding is blue, green, yellow given as 0, 1, 2. One hot encoding is converting it into a matrix and given 3 strings. Okay. Initialize weights and biases. Don't run the test case. It will not pass now. Just type the code and put. Okay.